Hi, my name is Lisa Cruz, and on this brief video, I'm gonna present what is my evidence of this class, that is the design and simulation of a mechanism. So let's start, okay? So the problem situation. The problem situation is the contamination that has been happening in our world, okay? So the problem is that we make more trash than what the earth can can reinstate itself. So we need to start making this type of economical changes to make a circular economy, so that what our waste is, we can transform into newer material and into newer products. So we come to the garbage that is cans. So the problem is, I can make the design of a can crusher. A can crusher would mean an effective can crusher actually would mean that you can squish all this material, that's aluminum cans, into a new process that can make newer cans. So it's a circular economy. Okay. So I took on an example of a 115 millimeter can and aluminum. Okay. So what did I do with this? I decided to set up parameters of what I wanted my current crusher to be, and I decided that I wanted this 115 millimeters plus 30 millimeters, which is 3 centimeters as length to put the can and then to crush it. So I made up a few sketches and I made up a few um, proposals of designs. So I have a total of 3, and then I make the 4 that is just basically the mixing of what worked and what didn't. So the mechanism I did for this, the main one with small alterations, is basically a slider, which consists on a crank and a moving a moving rod, a connecting rod. I'm sorry, and of course the small part that crushes the link that crushes the can. Oh, and the fixed link. I'm sorry. And okay, so I found out the first design. The first design is a total of 485 millimeters with a connecting rod of 300 millimeters and a 52.5 crank. I found that it was a relatively low torque. This torque I got it with simulation of SolidWorks and simulating the force that you need to crush a can. I found a paper that said that it was around 500 Newton meter uh, of energy that needs to be crushed. So I just put that force into SolidWorks and it gave me this torque needed from the crank. So the second one, I increased the sizing of the crank and also decrease the sizing of the connecting rod. And I found actually a bigger torque, but I didn't really know what it was, what if the 2 changes I made was. So I decided to lower the the no to I'm sorry, to increase this connecting rod a little bit more, not totally to the original one, but I found out that it was a good medium option with 37.6 Newton meter. I would have chosen this option, but the thing is that in my opinion, I don't think it's 10 centimeters is worth losing that amount of torque. And yeah, so I came up with the last option, which has a smaller crank and the same connecting rod as the first option. And I found that this decreased the torque a lot more, and so I went with that choice. So in my finishing product, this is a sketch. I made sketches for all of them, but I'm only exposing the final design because I think that's the only relevant part. And well, this is the final design, the SolidWorks design. On the paper I'm gonna attach with the video, you can find specific CAD drawings so that you can see all the dimensions. But yeah, it came up to be a really small crank and a long connecting rod. The materials, I found that the steel A36 steel is actually a really good option because it has a big, well, it can stand the tension and the force that it's going to be applied. And also I find some options on the market. I'm thinking of just cutting down a really big screen, I think that's what it's called, and just doing the holes, and that's it. The diameter and the length of the of the links, that is a 1/2 inch, and I believe 1.5 inch of 1/2 inch against 1.5 inch. That is common. That really is a common sizing for metals in the market. And yeah, I think that's all the design. There are more specific things in the file that I added with this video. Thank you.